All right. So, hello friends, welcome back. So, we are meeting again after a long time, I believe. So, I hope you have all given your JEE mains first attempt and must have been a pleasant journey so far, right? So, in today's lecture, we are going to start with our ongoing discussion that we were supposed to be finished, right? So, there are some topics that I missed to cover, and among those topics, they includes hyperbola, right? So, in the conic sections, we finished up till ellipses, right? So, and we couldn't have the classes after ellipse. So, we are continuing from that particular discussion, and let's continue with hyperbola from today's lecture onwards, right? So from today's lecture onwards, I'm going to discuss about hyperbola, and once I finish hyperbola, we will further move on with the other topics of algebra, right? And this is how we are going to proceed for your upcoming exam, right? And I believe that students who are currently in class 12, they must be also having the board exams coming up, right? So don't worry, we are going to start very soon for something for your board exam, especially for the practical part, right? So we are going to look into that particular aspect as well. Okay. All right. So let us quickly brush up on the previous topics, and with that, let us start our today's lecture of hyperbola. Right. So don't worry. Okay. So far so good. We have studied about ellipse, where we have seen that in ellipse it follows a very specific criteria that in case of an ellipse, we have seen that any point on the ellipse was basically having a criteria that if you take the focal distance of any point on the ellipse with respect to two focus and you take the sum of the distances, this particular thing was a constant in case of an ellipse, right? This was the basic physical condition for ellipse, right? So this we have seen so far. So in today's lecture, we are going to discuss about sorry, we're going to discuss about the difference that we will see in case of an hyperbola, right? If you look carefully, all the results of ellipse and hyperbola are going to be very similar. Okay, is this part clear to all of you? Okay, so if we talk about hyperbola, then we'll see that hyperbola specifically follows one more condition, is that if you take the focal distance of the hyperbola and you subtract that particular distance from the other focal distance and you take the mod of it, then for an hyperbola this particular thing will be a constant, right? So whenever the difference of the distances of your focal length is going to be a constant, then that is a condition for hyperbola, right? So this is a basic condition for an hyperbola, right? Like this is for ellipse, right? So this is a very simple condition, and with respect to this we'll see and how we can define the required equation, right? So whenever this particular condition is met, we call this as an hyperbola, right? So let us try to look forward and derive the basic equation or the general equation of the hyperbola, right? And along with that we are also going to understand about the geometric criteria, right? So with that, let's get started. Okay. All right. So the hyperbola also I can define it is a set of all points in a plane such that the differences of two fixed points or the difference of the distances between two fixed points, in this case the two fixed point at the focus, then if that is basically being constant in a plane, then we get an hyperbola, right? So if I try to draw the hyperbola, so let me try to draw the hyperbola for all of you. So I'm trying to, okay, I think I can put a scale over here, but let me check how can I adjust this angle. Okay, I see I can't adjust the angle. Anyways, fine. Um, Let us say this is my XY coordinate. Okay, this is my X and Y coordinate over here like this. So in case of an hyperbola, we call the X-axis as the transverse axis if your hyperbola is basically the standard form. Okay, and the y-axis becomes your conjugate axis if you're, again, this is for the standard hyperbola I'm trying to represent over here, right? So generally a hyperbola will actually look something like this. Okay, now many students think this is like a two branches of an parabola, but you are totally wrong, because this is not two branches of an parabola, rather they are separate set of conics equation, okay, because the equation of this conics is separately different from that of an hyperbola equation, right? So if I look about the terminologies, so I can take any point on this. So the focus will be somewhere over here. Let us say this is f1 and let us say this is f2, okay, and this is the center of the hyperbola, okay. So this is the center of the hyperbola, and these are the points where your conics meets the transverse axis is called as the vertex, okay. This is the vertex, okay, and these are called the focus, which you are already familiar with, and and the main important thing is that this particular distance minus this particular distance is going to remain a constant, right? So that's the basic understanding we will have on hyperbola, right? So with this basic understanding, let's now dive into discussing about the standard equation of an hyperbola, okay. So if I talk about the standard equation of hyperbola, if I talk about the standard equation of an hyperbola, so let us try to derive the standard equation of the hyperbola, right? So how can I do that? It's fairly very simple. So again, so to discuss about the standard equation of the hyperbola, what I'm going to be doing over here is that let us first of all consider the focus of the hyperbola. So let's the foci of the hyperbola be at, so I'm defining from my end, let us say there are basically two fixed points plus or minus c comma 0, right? These are defined as the focus of the hyperbola, right? Such that the midpoint of the focus is going to be centered, right? So it is defined in such a way that the center becomes the origin 0 comma 0, right? Now according to the definition, if we define the hyperbola in the following manner, then according to the definition, if I take up any point like and take the distance from the fixed point f1 and the other point other fixed point f2 and take the difference of these distances, this should come across 2a, which is basically a constant. So I'm calling this as a constant 2a, right? And this derivation follows a similar expression that we have seen in case of ellipse, right? So let us say that this 2a distance is less than 2c. That means here a is less than c. That is what I'm going to define, right? Okay, now having this definition of the hyperbola over here, then what I can do, I can consider this point P as some variable point x comma y for which I am going to find out the locus, right? So based on this condition, so if I apply this condition over here, it is nothing but the distances of the x comma y from first point, that is c comma 0, and the other point which is minus of c comma 0. So if I do that, the distances will be coming out as x minus c whole square plus y square plus of square root of x plus of c whole square plus y square, and this particular distance should be equal to 2 times of a, right? Okay, sorry, I made a mistake. It should be subtraction, right? The differences, and I should have put a mod over here, right? Is it clear to all of you? Right, now having this thing done, now I can further simplify. What I can do over here is that maybe I can try to square both the side and rearrange the terms. So it is basically based on the algebra. So you can take this on the other side and you can play around with the algebra, right? And then you can take a square of it, right? So so if you take the square on both the sides, so I'm writing over here squaring both sides, okay. So I'm squaring both side, we get, so squaring both side we get this as equals to 4a squared plus 4a times square root of x minus c whole square plus y square and then we'll have the x minus c whole square plus y square, right? This is the expression we will have now, right? So we can further simplify this. So if you try to simplify this expression, right, it is based on simple algebra. So what I can suggest is that you expand the terms and then you cancel out the common terms, right? So on simplification, we will attain this kind of terms, right? This would come something like this, okay? So if you simplify, then you will get like this particular, right? And again, if you take a square on both the side, we will end up getting the terms again on simplifying something like this, okay? which is very similar to that what we have obtained for the case of an ellipse, right? So if you look carefully, it is very similar equation that we have obtained for case of an ellipse. However, the only thing that is different is the negative sign over here, right? And if you remember, in case of an ellipse, we also did call this, we also called this expression, this c square minus a square expression, as some constant b square, right? So similarly, we're going to do over this also over here, and therefore the further standard equation of the hyperbola can be given as x square upon a square minus y square upon b square is equal to 1, right? So this becomes my standard equation of the hyperbola. Okay, so this is my standard equation of hyperbola. Okay, so this becomes my standard equation of the hyperbola. Okay, so this is how we can define the standard equation of the hyperbola. Is this clear to all of you? Do you have any questions? Any questions so far? Okay, do let me know if you have any questions. Okay, we will try to discuss. All right, is this part clear to all of you? Okay, so far so good, and then we can now proceed for understanding then how from this equation how can we derive the eccentricity. Okay, because eccentricity is a very important factor. Okay, and eccentricity in conics is actually defined as the distance of the point from the focal, let us say from focus, that is defined as s, and divided by the perpendicular distance of that point from the directrix, right? So that is what we are defined as eccentricity, right? So in this case, the eccentricity would be, so if I take up any point, so eccentricity would be the distance from, so the distance from, maybe we can define the distance from center to focus. Okay, we can also define the eccentricity in case of a hyperbola as the distance from center to focus divided by the distance from center to vertex. Okay, center to vertex. Now if you are having any question that why are we defining this thing like in this manner, right? So you might also have a question that why do we want to define this following thing and in this format, right? So we'll come to the answer of it, right? We'll come to this particular thing, but in case of ellipse also we have defined eccentricity as degree of flatness of that ellipse, right? In that manner also, and similar to that particular notation, we are defining the eccentricity of an hyperbola in the similar, right? In the similar. Okay, so is this part clear to all of you? Is this part clear? Okay, so now once we understand this, then therefore this particular thing can be written as this thing, the distance of the center from the focus is given as c upon a, right? This particular ratio can be given as c upon a, right? Now we have to define from here, we have to derive an equation relating the eccentricity. So I can take square on both the sides, so it will be c square by a square, and I know c square is basically a square plus b square divided by a square. And therefore ultimately I will obtain a equation something like 1 plus b square by a square, right? So this, therefore I will get another equation that is a square e square would be equal to a square plus b square, right? So this is one of the equation, and also I can say eccentricity would be equal to square root of 1 plus b square by a square. Okay, so this is a simple way of denoting the eccentricity for an hyperbola, right? So in terms of this given geometric parameter, we can now define eccentricity as follows. So given that we know the general equation of the standard equation of the hyperbola, we can therefore define that what is the eccentricity of the hyperbola. Okay, is this part clear to all of you? All right. So having this particular thing done, now we can also say that we can also write the standard equation of the hyperbola as follows. So we can now write the standard equation, we can now write the standard equation of the hyperbola as x square by a square minus y square by, now instead of b square I'm writing at a square e square minus of 1, right? And this is also equal to 1. So this is also another way to write b square, right? And from here we can also get the coordinate of my focus, because focus was defined as plus minus c comma a, c comma 0, right? So from here I will get the coordinate of the focus. Okay, I'm writing foci, so this is a plural of focus. So the coordinates of focus are plus minus a comma 0. Okay, so these are the coordinates of my focus. So having known the eccentricity and the standard equation, I can therefore define the coordinates of the foci of the hyperbola. Okay, so and also coming to this particular idea, we also have another very specialized form of an hyperbola, that is called as rectangular hyperbola. Okay, there is some set of hyperbola which is called as an rectangular hyperbola. Okay, so what is a rectangular hyperbola? We'll discuss about it in details, but for time being we can understand rectangular hyperbola in terms of eccentricity. Okay, it is a specialized case of an hyperbola when both your a and b, the constant a and b, are equal. So that is the important thing. In case of a rectangular hyperbola, you have your constants a and b equal, right? So when this constant a and b's are equal, in this case we call this as an rectangular hyperbola or an equilateral hyperbola. Okay, and in this case the equation of the hyperbola becomes something like this. Okay, and I think many of you must have come across this kind of equations in your uh, course or curriculum so far, right? So if you try to find out the eccentricity for this kind of hyperbola, so you use the formula 1 plus b square upon a square, where your a and b are equal. So if I put a and b are equal, this ratio will be 1, right? So 1 plus 1 is going to be 2. So therefore ultimately we will have the eccentricity of this kind of rectangle hyperbola will be always be equal to 2. Okay, is this part clear to all of you? Is this part clear? So moving forward, therefore now again I also come across, now since we defined the eccentricity as the following way that was defined above, now it is also possible to define two lines or two perpendicular lines to the transverse axis, that is called as directrix, right? So we can also define the directrix of the hyperbola. So how do we do that? Now in this case again I'm going to use the concept of eccentricity, right? So I can define two possible straight lines, that is x equal to plus or minus a upon e, which will be called as the directrix of the hyperbola, right? So it is possible that corresponding to the focus, focus we can define, or corresponding to each other focus we can define two lines which satisfy the focal property, the focal directrix property of the hyperbola. What is that? That any point from the focus, let us say f1, divided by the perpendicular distance, corresponding perpendicular distance on this corresponding directrix, should be equal to eccentricity, right? This is a very standard form of the standard definition of a conics or any general conics, right? Therefore, and similar way I can take the other focus, that is f2, and the uh, perpendicular point on the other directrix m2, that will also be equal to the same eccentricity e, right? Therefore from here I can define two different straight lines which are called as a directrix, right? So therefore if I draw the diagram, so this is my conjugate axis, this is my transverse axis, right? So therefore, for one branch of the hyperbola with the focus f1, there will be one straight line like this, which is perpendicular to the transverse axis, and for the other branch we will also have another straight line perpendicular transverse axis like this, and these are the two directrix. Okay, these are the two directrix. Okay, these are the two directrix located at, so this is located at minus of a by e, and this is located as plus of a by e. Okay, so these are the two coordinates of the directrix, so two equations. Okay, x equal to minus a by e is one of the directrix, and another directrix x equal to plus a by e, right? So this is the directrix equation, right? And in a similar manner, once you know the directrix, you can take up any point and you calculate this particular distance and this particular distance. So this will be pm1, so pf1 would be e times pm1, which is easy to calculate. Let us say this xp1 is given as x1 comma y1. Okay, this p1 distance is given as x1 comma y1, right? So if I again carry out this exercise to calculate pf1, that is eccentricity times pm1, and pm1 is easy to calculate, that is basically x1 minus the directrix distance on the origin. Okay, that is basically a by e, right? So this will simplify and we'll get e times x1 minus of a, right? And similar manner I can also calculate pf2, and that would equal to x1 times e plus of a, right? So this is my first equation and this is my second equation. So having these two equations, if I subtract both the equation, if I subtract 2 from 1, okay, if I subtract these two equations, what I'm going to get? I'm going to get PF2 minus PF1 would be equal to 2 times of a, which is basically a constant, right? So only when you subtract, this basically becomes a constant, right? Is this part clear to all of you? Okay, so we again prove that this is also valid in case of the standard equation of the hyperbola, right? Now, having the standard equation of the hyperbola, we can also shift the hyperbola such that the center is not at the origin. Okay, so if I have another set of an hyperbola such that the center is shifted at any other point h comma k, and the equation of the hyperbola remains the same, or the flow of the hyperbola remains the same, such that the transverse axis is just parallel to the x-axis and the conjugate axis is just parallel to the y-axis. Okay, this particular arrangement remains the same. In this case, the equation of such shifted hyperbola whose axes are parallel. Okay, the very important thing is axis. Okay, axes are parallel. Okay, axis of the are parallel to the coordinate axis. Okay, are parallel to the coordinate axis. Okay, in this case, and the center is given at any arbitrary point h comma k. Okay, so just the axis is shifted, center is just shifted. Okay, remains, the axis remains the same. So in this case, the equation of the such hyperbola is given as x minus h, so just a shifting of the origin, by a square minus of y minus k whole square divided by b square is equals to 1, right? So this becomes my general standard equation of such an hyperbola whose the center is shifted, rather all the things are same, right? So from here we can also comment on what is my foci. So my foci would be now AE, but there will be one more point, that is h. Okay, so h will come as an additional thing. Okay, so let me write this in a better way, like h plus minus a comma k. Okay, just a shift. Okay, just the shift of the origin. Okay, now, and following manner we can also define my directrix in this case. Okay, so my directrix in this case would be, would become x equals to, just h will come up over here, plus minus a by e. All the things remains the same. Okay, so these are the two important modification that we will have. Okay, now having these things understood clear, so having these things done, we can now move on to the actual definitions or the basic terminologies regarding any standard hyperbola. Okay, or it is also general true for all other set of hyperbola. Okay, so what I'm going to do over here is that I will try to draw the hyperbola, and we will, with that drawing, we'll try to understand about the basic terminologies. Okay, so I'm not going to write again the conjugate and the transverse axis. It is well understood that you have so far get it, right? So let us draw the two branches of the hyperbola like this, right? Now, so important thing to note is that if I take up any point over here, right, and let us say I take a points over here P1 and I take a point over here Q1. Okay, and if I join 2 points on the hyperbola, okay, if I join 2 points on the hyperbola, then this is called as a, and passing such that these 2 points, I join this line such that this is passing to the focus, then I call this kind of chord as a focal chord, right, which is very straightforward and obvious, as we have seen in case of an ellipse, right? Similarly, if I draw a chord such that this focal chord is perpendicular, and like this, and then in this case we call this kind of perpendicular line, and it's a focal chord which is perpendicular, is called as an latus rectum, right? So this is we called as a latus rectum, right? Now in the question it will be asked to find out the length of the latus rectum. How do we do that? So it's very simple. If I want to find out the length of latus rectum, so if I want to find out the length of the latus rectum, let us call that as LR, as the length of the latus rectum, and that would be equal to, so how do we find out the length of the latus rectum? the simple thing that we can do over here is that at x equal to AE, let us take the point x equal to AE, and I just perpendicular go and find out the y coordinates, right? So if I take a line x equal to AE and I try to solve it with the standard equation of my hyperbola, I'll get the coordinates of the y where the curve is touching, right? So if I solve this, I'm going to get some equation like this, which I can further simplify. Okay, so this is going to cancel, and therefore I'll get the value of y as something as plus over minus b square by a. Okay, so I will get the two coordinates of the y. That means what I'm doing is that I'm trying to draw a line. So this particular line I'm trying to draw, and I'm trying to see where these lines are cutting the hyperbola or the one branch of the hyperbola. Okay, from that I am going to find out. So this x is basically AE. Okay, this x is AE comma y1. Okay, and this also AE comma y2. So once I have found out this y1 and y2, these are basically b square by a, another is negative times b square by a, I can easily now plot the latus rectum length. Okay, the latus rectum length would be now equal to 2 times of b square upon a, right? So this is a very simple relation that we have also seen in case of an ellipse, right? So all the results are more or less the same. Only thing that is going to change is just the sign. Okay, so there is a minus sign instead of the plus sign that we have seen in case of an ellipse, right? And also I can define this latus rectum length as follows. So I can now further simplify, and I can write this b square in terms of my eccentricity, such that I can represent this as a square e square minus 1, right? So that will become, so if I divide by a, it will become 2a times e square minus 1, and I can further simplify this as e, if I take it common, it is going to be like this, something like this, right? Now if you recall, this particular distance AE minus a by E is nothing but, so this is the center to focus distance minus the center to the point where your directrix is there, right? This is the center to directrix and center to focus, right? So this is the distance between the focus and the corresponding foot of the directrix. Okay, this is basically clear. So we can also find out latus rectum as 2 times eccentricity times the distance between the focus and the corresponding foot of directrix. Okay, is this part clear to all of you? So let me denote the points A1 over there. So this is basically, so if I have the directrix, so this point is called as my A1 point. Okay, is this part clear to all of you? Okay, so far so good, right? So all the things are more or less similar, but however, in respect to ellipse, what we have seen, we'll see that in case of an ellipse, we had either the x-axis was a major axis or the y-axis was a major axis, right? However, in case of an hyperbola, if my transverse axis becomes the conjugate axis and the vice versa, that means that if I have to define a hyperbola like something like this, okay, if I have to define a hyperbola something like this, where my y-axis becomes my transverse axis, okay, where my y-axis becomes transverse axis and where my x-axis becomes the conjugate axis. Okay, so in this case, this kind of hyperbola, we call this kind of hyperbola as an conjugate hyperbola. Okay, conjugate hyperbola, and there is a very simple way to understand this kind of hyperbola is that the standard equation of such conjugate hyperbola is going to be equal to x square minus by a square minus y square by b square should be equal to minus of 1. So this is very important. Okay, this will be minus of 1. Okay, unlike the standard hyperbola that is equal to 1, it will be just minus of 1, and whenever you see this kind of expression coming up, you will have to understand this is the equation of an conjugate hyperbola. And for this kind of conjugate hyperbola, the eccentricity is basically given as square root of 1 plus a square by b square. That's the only difference that you will note, right? So this kind of for this kind of hyperbola, we will have the eccentricity. The only change that we will have in the eccentricity is like this, right? Also, we can also go about and define another parameter, that is, let us say this is for conjugate hyperbola CH. Okay, ECH is given like this, and earlier we have seen that the eccentricity for normal hyperbola whose equation is given as x square by a square minus y square by b square is equal to 1. So this is, we are calling it as normal hyperbola, and this we are calling it as conjugate hyperbola. CH stands for conjugate, A stands for normal hyperbola. Okay. So if we have that, we have seen that in this normal hyperbola, the eccentricity was given as square root of 1 plus b square upon a square, right? So these two are known to us. Then from here I can also calculate another expression. So if we try to do one simple expression or calculation, that is the eccentricity of hyperbola, normal hyperbola square, and the eccentricity of the conjugate hyperbola square, if I just add them up, if just take a reciprocal of them. Okay, just take like this, 1 upon eccentricity of the hyperbola square plus 1 upon eccentricity of the conjugate hyperbola square. This would be now coming out as 1. Okay, so these are very, very important criteria that we will see that it is satisfied in case of an hyperbola and the conjugate hyperbola. Okay, so maybe let us say that we know what is the eccentricity of my given hyperbola, and in the question it is asked to find out the eccentricity of its respective conjugate hyperbola. Okay, and that particular thing will something look like, so if I am going to draw the graph, so the normal hyperbola is something like this, right? And the conjugate hyperbola will look something like this. Okay, so it is going to form a set of symmetric curves, right? So it's going to form a set of symmetric curves. And an interesting part over is that, say, let us say this focus is f3 for the conjugate hyperbola, f3 and f4, and the focus of the normal hyperbola is f1 and f. Okay, and if I join all these focus, you will see that this is going to become a very symmetric figure. That is, in this case I will have f1, f2, f3 and f4 is a square. Okay, so I want all of you to prove this particular expression. Okay, you will see that this will be a square. Okay, this will be a square. So the question that you all have to solve as an homework for today's lecture is that please find out or prove this relation that it is a square. Okay, you have to prove this and come up with your innovative way of proving this relation. Okay, so try to see that whether you can prove it or not. Okay, rather things are very simple and straightforward. Okay, so we all know the coordinates, and then from there you can easily prove that whether it is a square or not. Okay, so please remember that what are the sufficient proof to prove it a square. Okay, all right. So you take, and the very simple way is basically you can see that the two diagonals are intersecting at a right angle. So that basically makes it a square, right? But however, I want a written proof. Okay, so please prove that with respect to the eccentricity. Okay, with respect to the eccentricity. So you use the eccentricity, this particular equation, in order to prove that this is a square. Okay, so with this we come to the end or conclusion of today's lecture. And in the upcoming lecture, we're going to discuss about the auxiliary circle, eccentric angle, and then following that, we're going to move about how we can parametrically define any coordinate on a hyperbola, right? So those will be the topics that we will be going to cover in our upcoming lectures. And with that, we're going to move into question solving. And then following that, as you all know that so far in coordinate geometry, you have to always solve the basically tangents and normal. So we're going to move into that particular aspect. Okay, so with this I thank all of you for today's lecture, joining this lecture, and with this we'll meet again in our next lecture. Thank you and hope to see you soon.